Hello students, good evening. Good evening students. Everyone has joined and I don't see a good evening message from anyone. Suman, good evening. What happened? Itna gussa? Ishtu kopa? Yake? Okay, hello Davangere students, good evening. Chitradurga students, good evening. And YouTube live students, good evening. How are you all? Yes, Amrita, good evening. Chitradurga students, good evening. Okay, Tumkur, Ballari students, Uttara Kannada students, good evening. ಎಲ್ಲ ಹೇಗಿದ್ದೀರಾ? So, students, please let me know, is my audio, is my presentation visible or not? Let me know, students. Okay, good. Suman, thank you. Sweetie, good evening. Others, let me know, Uttarakhand, JNV students, everyone, every JNV students. And Davangere students, there is no BA section today. Namma, good evening. How are you? Okay, others, let me know in the chat, is my screen visible, is my audio audible or not? Jaldi batao. Students, be quick in answering. Okay. So without your, let's say, yes or no, I can't proceed because there is no poll. Otherwise, I would have asked the poll. The poll has to be created. So from the next week onwards, the poll will be ready. Okay. So please let me know, students. Please let me know. Sweetie, let me know. Okay. So I think everything is good. Yeah, Davangere students, I will. Okay. I will. Don't worry. Okay. I will on the camera. But yeah, you need to answer whether the screen is visible or not. You are not answering that. Okay. So with that, I'll proceed with it, thinking that everything is fine. So good evening, students. My name is Saman, your physics faculty from Avantifellows. And students, what we were studying about Newton's laws of motion, and hopefully this will be the last session of Newton's laws of motion, students. So from tomorrow we might study what work, power, energy. Okay, work, power, energy. So students, before going to today's session, what we are going to talk about, okay? Let's quickly go what we are going to talk about. The first thing is what quickly recall what you have studied in the last class so that you can what solve numericals. So please students, everyone has to remember what tension, the friction, the kinetic friction, the static friction, the limiting friction, the Newton's laws of motion, everything. So I hope you remember all these terminologies. How are these come, where does this apply, how do you apply in what numericals, in numericals you need to know. Okay, then we will be talking about something called pseudo force. Okay, something called pseudo force, and we'll be talking numericals today. Then students, then it will be the summary of what this session. Okay students, is it good? Let me know in the chat. Yes, good. Yes Nama, work, power, energy will be from tomorrow. Okay. Yes. Okay, Uttarakhand students, thank you. Very good. Now, sweetie, let me know. Can you hear me? Madhiha, good evening. Now, talking about what we have studied in the last class. Okay, what we have studied in the last class. Good, sweetie, thank you. Now, we were talking about weighing machine. Yes or no? Let's say if there is a weighing machine. Okay, let's say if there is a weighing machine and I am sitting on that weighing machine, or let's say you. Sabko, agar if you don't mind, it's you. Okay, over here, whoever the student might be, and this is the weighing machine, and I told you that how does the weight come, how does the weighing machine shows reading, how does the weighing machine shows reading? Tell me students, what is the cause for it, what is the real cause for it? Let me know. In yesterday's class I have told you, you know that there is a normal reaction on what, on the like human, by the what, the surface, this surface, and there is a weight that is acting m into g. Yes, and you know that, yes, very good tumko students, you know that for the surface there will be a normal reaction by the what, by the human on the surface. Yes, Now, due to this normal reaction, which is basically equal to what? M into G, which basically tells about what? The weight. And that is the reason you get this reading. This is weighing machine. You get the reading. Yes or no? Over here, let's say this is your weight. That is what? 63 kgs. So it is due to the what? Due to the normal reaction. Yes or no? Students, let me know. Isn't it due to the normal reaction? Yes, good, man, very good. Very good. Then, yes, Chitraduga students, very good. Then, students, we talked about what? Apparent weight. Yes or no? What was happening? Even if the weighing machine was good, weighing machine was proper, there was what? There was weight difference. There was change in weight. Yes or no? The actual weight to the what? The weight that you are seeing. And that change in weight is called what? Apparent weight. Yes or no, students? And in that, we saw this lift case. Yes. Yes or no? We saw this elevator case. In that elevator case, yes, elevator. In that, we saw numeric cases. In the case one, we saw that if there is a lift and there is a what weighing machine and there's a human being, yes, students, and there is an acceleration. If this lift is moving with the acceleration A, students, what was the normal reaction that we got? What was the normal reaction that we got? Students, let me know. Do you remember this? We got the normal reaction as what? M into G plus A. Yes or no? This is due to what? Here, if the lift is going upwards, if the lift is going upwards, you feel what? The heaviness. Yes or no? Yeah. And that is due to what? The increase in the normal reaction. That is M into G plus A. Yes or no, students? Yes. Yes or no, students? Let me know in the chat. Very good. Others? Good. Okay, Chitraga students. Good. Sweetie, good. Okay. Then, talking about the second case. What was the second case? Case 2 was when the lift was going down. When the lift was going down, weighing machine, and there is a human and who is sitting over here. And if the lift is going down, students, what was the normal reaction we got? Normal reaction that we got, let me know. Do you remember the normal reaction we got? That is M into G minus A. Yes or no? Here, what is happening? This is downwards. Yes. What is happening over here? You are feeling, you feel what? Lightness. Yes or no? You feel very, very light. Yes or no, students? कभी लिफ्ट में गए हो या तो लिफ्ट में ट्रैवल ಮಾಡಿದಿರಲ್ಲ? Yes. Now, next we talked about the case when what is happening over here? When the acceleration is what? Constant. When weighing machine and if there is a human being and if the acceleration is 0, so what was the case, students? So what was the case where we saw that what basically this V is constant? It is moving with constant what velocity. So what was the case, students? Then we got the normal reaction as what? N equal to M into G. Yes. Here you are not feeling any weight like heaviness or lightness. Yes or no, students? Let me know. Yes or no? These were the cases that we talked about. Yeah. Good. Next we talked about what? The last case that we talked about was, do you remember what was the last case? Case 4. This is case 3. What is the case 4 that we talked about? Yes, when it was free fall. So free fall mein kya hota hai? Basically in free fall, let's say if this is a lift, it is moving down and the acceleration is basically equal to the what? G, acceleration due to gravity. Yes, if there is a human being and is sitting in this plane, and what is happening over here? You know that there is a normal reaction, and this normal reaction comes out to be what? This is mg. So mg minus n equal to m into a, and mg minus n equal to m into g, and n comes out to be what? Mg minus mg. That comes out to be 0. Yes. So for free fall case, what is happening? You are feeling no normal reaction. Yes. Yes, students. YouTube live students, let me know. Okay. See, and also I guess I gave a homework problem for you guys. I gave a homework problem. Did you try to solve it? There is a homework problem. So did you guys were able to solve it? Yes or no? Where you had to find the acceleration. So the answer for it is basically a is equal to 8 meter per second square and a equal to 1 meter per second square. Okay. Okay, who is it? Suman, please check your answer. Okay. Is it 1 meter per second square or not? Okay. Okay, sir, solve. Tumko students, I'll be solving this homework in some other class. Okay, not today. I'm giving that time to solve for you, but today I won't be solving it. Okay, we'll have a separate, let's say, numerical session of Newton's laws of motion. Okay, like when I'm doing work power energy, so there'll be one session which will be dedicated to for what? For numerical laws, because these questions comes in what? JEE. Okay, JEE or NEET. So I want to focus on, let's say, a session which will help you to gain all the knowledges on JEE and NEET questions. Is it good, Tumkur students? Yes. A dedicated class. Dedicated class. Okay. Is it good, Tumkur students? Okay. Good. Good. So don't worry. We'll be solving about it. Okay. A dedicated class will be for JEE and NEET questions. Very good. Others, is it good? Okay. One new student, Priyansi. Good evening. Welcome to today's session. Okay. Nice. Maria, good. Thank you. Now, today we'll be talking about something called pseudo force. Now, students, what is this pseudo force? When you hear about this pseudo force, what comes into mind? Like why this pseudo force came into picture, or what is this pseudo force? Can anyone tell me? Or what does pseudo force means? बता सकते हो? What is this pseudo force? Let me know. Okay, good. Imaginary force. Okay, someone is saying this pseudo force. Suman is saying this pseudo force is what? Imaginary force. Okay. Okay. Someone is saying Uttara Kannada and Ballari students are saying non-inertial. Very good. Okay, they went very technical things. Okay. But can I say this force is a dhoka force? क्यों धोखा फोर्स है? ये असल में एग्जिस्ट ही नहीं करता ना. It doesn't what exists at all. This is basically what? Imaginary force. अगर ये एग्जिस्ट ही नहीं करता तो बेसिकली क्या कर रहा है? धोखा दे रहा मैं, है कि नहीं? है कि नहीं? जैसे मान लो मैं बोलूंगा आपको, मैं आई गिव अ गिफ्ट टू यू, बट मैं हर टाइम बोलूंगा कि गिफ्ट दे रहा हूँ, लेकिन कभी दूंगा नहीं. इज बेसिकली धोखा ना. या इज गुड. यस. सो ऐसा वो धोखा फोर्स. लेकिन अगर ऐसी बात है, अगर ये धोखा फोर्स है, व्हाट इज द यूज ऑफ इट? व्हाट इज द यूज ऑफ इट? अगर ऐसी बात है तो इसकी यूज कहाँ आ गई, ये बताओ मुझे. Force experience. Okay, Davangere students, always remember it's not a force experienced by the body inside a frame. It's not an experiencing force, students. It's just a force that this is for Davangere students. This is a force that we make use of in order to do something. That is what. If that is the case, what is the use of it? मुझे ये बताओ आपने सूडो फोर्स के बारे में देखा है, पढ़ा भी है, लेकिन व्हाट इज द यूज ऑफ इट? अगर ऐसी बात है, व्हाट वाज द नीड ऑफ इट? सर, नीड एंड जेडी सेक्शन. Amrita, it will be in the next week. Okay, don't worry, it will be in the next week. Amrita, are you in seed group? Let me know if you're in the seed group. do you know the let's say how to join to the seed group and all? Let me know. Non-uniform action to use Newton's law in okay. Tumku students are saying right answer. Very good. See, the problem was Newton's laws of motion. Yes, Newton's laws of motion. Yes or no? There were certain times, or let's say certain, let's say, how do I say it? Certain concepts. In certain concepts, this Newton's laws of motion was not holding basically. Okay, or let's say there were certain problems. There were certain problems. There were certain problems that arise. Okay, the problem was, see, you couldn't apply. You were not able to apply, not able to apply to apply Newton's laws of motion directly. Okay, understood, students? So what was happening? So Newton's laws of motion, but there were certain problems that arise, and you couldn't apply what Newton's laws of motion directly. Now, if that is the case, what was that problem? What was the problem, students? Can you tell me what was the problem? Yes. What was the problem? The problem was Newton's laws of motion started. Okay, sorry. Newton's laws of motion started depending on observer. इसका मतलब क्या है कि अगर कि observer कहाँ है, whether he is with the let's say I'm observing something, I mean in that frame or I'm in a different frame, so that problem arises. Okay, so it started to depend on what observer. So for observer there were two frames that were defined. Can you tell me what are those two frames? Can you guess? Or I know you know those two frames. What are those two frames? Can you tell me, students? We have talked about it. What are the two frames that the observer it's defined for? The observer it is defined. Okay, Amrita, we'll do one thing. I'll send the Telegram link over here. Okay. Then you can join the seed group. Good. Okay. So what were the two frames? Normal by surface to object and by object to the surface. No, sweetie. I'm asking what are the two different frames? मान लो अगर एक ऑब्जेक्ट को देख रहे हो, ऐसा कर सकते हो ना. You might be, if this is ground, you might be over here watching it, or you might over here also. You can be over here also. So those two frames were what? Inertial and non-inertial. Yes or no? Yes. Over here, you know that in inertial frame, you know that the acceleration was 0. Yes. So what does it mean? The velocity was constant. And over here, we can apply the Newton's laws of motion directly. Yes or no? We can apply the Newton's laws of motion directly. Yes. And you know that here we solved numerous problems. Yes or no? Those numerous problems were what? They were pulley problem. They were the tension problems. Here, you know that everything was taken in terms of ground. Dekho, ground mein, I was there and I was seeing this pulley which had mass. Yes or no? Yes or no, students? So I was in ground. The observer was in ground. Yes or no? Now, in non-inertial frame, basically what is happening? The acceleration is not 0, students. And you know that if acceleration is not 0, then what is happening? The velocity is changing. Now, you know that if this is the case, you can't apply Newton's laws of motion, because Newton's laws of motion is applied for what? For constant or velocity, or the acceleration is 0. And see, since here, what? Here the Newton's laws of motion were not valid. Not valid. So that is why it was called not inertial frame. It is called inertial frame because you know that Newton's laws of motion, basically the second law of motion is also called what? Inertial what? Inertial law. Yes or no? ऐसा एक नाम है ना, एक और नाम है ना? Yes. Yes or no, students? Let me know. Good. Others? Good, good. Now, very good. Now, students, okay, sweetie, can you do one thing? Need a small help from you. Can you send the Telegram link, see the Telegram link over here through the chat box? Please send me. Can you do that? अगर आपके पास टाइम है तो ओके ना? Okay. Now, here, as I said, now there was two frame. What was the frame? One is inertial frame, and the second is non-inertial frame. But thing was, we wanted to apply Newton's laws of motion in what? In non-inertial frame also. Non-inertial frame also. Now, in order to do that, students, we had to do some jugaad. कुछ जुगाड़ करना था. This jugaad will help us what? Help us apply Newton's laws of motion for what? Inertial, non-inertial frame. Yes or no? Now that jugaad was basically what? Pseudo force. That jugaad was pseudo force. अब पता चला कि pseudo force originate कहाँ से आया? Yes, students, let me know. Sweetie, thank you. Students, let me know. Like, did you understand where this pseudo force came into picture? What was the need for it? Basically, in non-inertial frame, we couldn't apply what? We couldn't apply the Newton's laws of motion. So, कुछ ना कुछ तो जुगाड़ करना था. अगर जुगाड़ करना है तो क्या करना पड़ेगा? हमें एक फोर्स लेकर आना था. वो था pseudo force. Okay, is it good? Okay, Chitradurga students, just a second. Sweetie, thank you. Amrita, please take this, okay? I'm giving you a link now. I'm giving you a link. I hope I can copy it. I hope I can. Okay, here is a link for Telegram. So, Amrita, please join the Telegram group, okay? Please join. Okay. Okay. Chitradurga students, listen, or others. Over here, as I said, what was happening? You know that I told you that the Newton's laws of motion started depending on what? Newton's laws of motion started depending on what? The observer. Means what? See, if there is a body and we need to check let's say we have to check the body. Check the body. Now, over here, there is a ground and there is this frame also where the body is. Okay. Got it? If there is a body over here. Okay. Now the observer can be in this frame, let's say in the ground, or it can be in this frame where the object is. Now, students, that frame was called inertial and non-inertial frame of what? Reference. Now, you know that in inertial frame, basically in inertial frame, the acceleration is 0. And you know that if the acceleration is 0, the velocity is constant. Yes. And basically, the Newton's laws of motion can be applied for inertial frame directly, because Newton's second law of motion is applied for A equal to 0. Okay, for what? Constant velocity. And we solved a numerous problems. Yes or no? So over here we solved this problem, the pulley problem. The pulley problem. Yes, where I was sitting in the ground, I was checking the pulley. But there was this non-inertial frame where we couldn't apply what? We couldn't apply Newton's laws of motion. We couldn't apply at all. For that case, what? So basically non-inertial frame, what is happening? There is one acceleration. Okay, जो ये फ्रेम होता है ना, ये जो फ्रेम ऑब्जर्वर का, उसके लिए एक एक्सेलरेशन हो जाता है. Don't worry, I'll explain it using example. Okay, now you know that there is this changing. What changing? What is changing? The velocity is changing because acceleration is not constant. Now student, the basic thing was, देखो आपको पता है कि न्यूटन्स लॉस ऑफ मोशन होल्ड करता है फर्स्ट सेकेंड थर्ड, लेकिन अगर हमारे नॉन इनिशियल फ्रेम में वो होल्ड नहीं कर रहा है तो वी हैड टू डू सम जुगाड़. Now that jugaad was basically what? Bringing this pseudo force. What? Or introducing what? This pseudo force. Yes. Let me know, students. Yes or no? Chitrika students, let me know. Did you get it? Okay, Amrita. So you can ping me over there also. Okay, you can ping me over there. My name is Samanvit though. Okay, okay. Others, let me know. Yes, very good. Now students, let's do one thing. Now let us try to understand. Now let us try to understand using an example. Okay, now understand using an example. Let's say I have a lift. Okay, and there is a mass m which is attached to a string. Okay, to a string, and there is a, okay, just a second. It is attached to a string now, and this lift is moving with the acceleration a, and I'm an observer. I'm standing over here, which is in the ground. Now, students, if I ask you, what is the FBD for this? Can you tell me what is the FBD? How will the FBD be? Can I say there's a tension that is acting over here, and there's a weight that is acting m into g? So FBD of this, what mass of the mass, FBD of the mass, can I write as m? There is a tension. There is what weight that is acting. Yes, yes, students, and you know that there is a what acceleration that is happening over here. So can I write t minus mg equal to m into a? Yes or no? And can I write t is equal to mg plus m into a? ये पता चला? Yes, very good. When the what observer is in ground. Yes or no? Is it good? Very good. Now the second case would be, others, let me know. Did you understand it? Now, here, what will I do is, I'll take the lift, I'll take the same mass m, but students, the observer will be the inside of the lift. And the observer, the axis. Okay, sweetie, just a second. And the lift is moving with the acceleration a. Yes, okay, here. But other students, take it. Yes. Let me know if there is any doubt, okay? Let me know if you have done with this slide. Okay, Badari students. Sweetie, thank you. Badari students. Priyansi, are you able to understand? Are you able to understand what I'm talking? Badari students, let me know. Okay, good. Nice. Suhaib, Suman. Okay, good. Now, students, tell me one thing. If I'm going to draw the FBD of the mass, what will be the FBD of the mass? Let me know. Very good. Let me know. मुझे ये बताओ कि एक लिफ्ट है, ठीक है, और एक मास है मेरे ऊपर, ठीक है. Okay, you can't see this. If there is a mass that is hanging, okay, can you not see it? What is happening? Okay, you can't see it. Can you see this? Just a second, let me change something there. Okay, now can you see this? Okay, now, okay, Madhya, just a second. I'm sending you the link. Madhya, here is a link. I'll send you. Okay. Now, students, tell me one thing. If I'm inside the lift, and there is a mass that is hanging over here, if there is a mass that is hanging over here, and the lift is moving with the acceleration a, will this object be having any acceleration? ये बताओ मुझे. Will the object, let's say if there is an object, will this object be acceleration? ये hang हो रहा है और मैं भी इसके अंदर हूँ, ठीक है? I'm inside this. Will this object be having any acceleration? Let me know. Students, let me know in the chat. Yes or no? If I'm inside it, Okay, if I can't see anyone's message. See, I'm asking if I'm inside the lift. If I'm inside the lift, will there any be acceleration for this? I'm asking. If I drew the FBD of this mass, you know that the mass will having some tension over here. There's a tension. There's a weight acting over here, M into G, and you know that acceleration is zero. Yes or no, students? Now can I write T minus what? You know that there is an acceleration with which it is moving. So can I write T is equal to M into G? ये हो जाएगा ना? Yes or no? Yes or no, students? Let me know in the chat what is happening. Okay. Amrita, what is false? I didn't get you. Yes, very good. Now, yahan dekho, just observe here. You got different values of t. What was happening? For the first case, t is equal to mg plus ma. And for the second case, what is happening? T is equal to m into g. अब देखो, अगर मैं बाहर हूं तो क्या रहा है? T is equal to mg plus ma. And अगर मैं अंदर हूं, T is equal to m into g. So me sitting outside, I'll call the inside guard. I'm like, I got the tension value as mg plus ma. What was your tension value? The tension value I got was T is equal to m into g. T will be like T is equal to mg. How can that be possible, students? How can, if the mass is same, if it is what having this same tension, it is over there only, how can we get different tension when we are outside and inside? How this is possible? That was not possible, right? It can't be possible. Then what we did was we went to lab and checked which was correct. Checked which was correct. And we came to know that T is equal to mg plus ma was correct. This was correct. But what did we do wrong over here? What was the case we did wrong over here, students? Let me know. What was the case that we did wrong over here? Why did we get T is equal to m into g when the observer was inside this mass? What was something that we didn't take care of? Can I know? The thing was, students, the thing was, if it is moving with the acceleration a, you took this acceleration to be zero. But students, this human over here or me will have an acceleration a. We didn't consider this, students. Now, you know that T is equal to m into g hai. But you know that the correct equation is what? T is equal to mg plus ma. For this reason, students, there was a pseudo force what that came into picture, and what students, for that reason we had to consider this pseudo force. And how do you do it? How do you consider the pseudo force, students? What? How do you do it? You write the formula. You apply the formula what? As what is the formula? Fp, the pseudo force Fp is equal to minus m into a. Basically what you do is you apply a pseudo force for the observer in the opposite direction, and that will be m into a. And this is the formula, students. Did you get it? Yes. So whatever happening, if this is a non-inertial frame, yes. So what you need to do, you need to apply this is a pseudo force. This is a pseudo force that is being applied, and it will be what? In the opposite direction. This negative sign indicates what? You need to apply in the opposite direction. Bas, काम खत्म. Got it? The reason what? See, you know that tension over here was different. You got different value of tension, and you know that the correct value of tension, this is the correct value. Yes. And you knew that what? Tension doesn't depend on what, students? It doesn't depend on frame. That is means from where you are observing, from where you are observing. Yes. So that is the reason we came to know that this is not right. But if that is not right, by applying what Newton's laws of motion, then what we had to do? We had to create a pseudo force. Yes, we had to create a pseudo force. And that pseudo force has this formula. Yes. Yes or no, students? Let me know in the chat. Did you understand it or no? Yes or no? Priyanshi, very good. Okay. Amrita, T equal to mg plus ma is the right one. Okay, T is equal to mg is not the right one. Hence, we have to apply the pseudo force. Okay. Amrita, did you get it? Okay, students, very good. Everyone is saying. Others, let me know. Uttarakhand students. Ansari, are you able to understand? Were you able to understand? Okay, very good. Others, once again. Okay. Now, Ballari students, see over here, the first case was I was here. Okay, I was in ground and I had this lift. This is the lift. Okay. And I am like the lift is moving with the acceleration A and I'm observing this mass. Now for this mass, if I draw the FBD, I got the tension value as T is equal to mg plus ma. This is clear, Ballari students. Now the second case was I was inside the lift. Now if I'm inside the lift, this mass will what looks like what it is stationary. Looks like stationary. Now if that is the case, students, if I draw the FBD, I get the tension value as what T is equal to m into G. Now for two different frames, I was getting tension, two different tension. But tension doesn't depend on does not depend on what frame. If that is a students, I went to lab and I checked that this T is equal to mg plus ma is the right one. Now if that is the case, what did we do wrong? What was the exact thing we did wrong? See, you can't say that here Newton's laws of motion was wrong. Obviously you can't say that, right? Because Newton's laws of motion holds. Yes. And you can't say that the FBD was wrong. The FBD also was correct. Both was correct. Then what did we do wrong? The only thing we did wrong was we didn't consider acceleration of this observer. Okay, we didn't didn't consider the acceleration of observer. Now, due to the acceleration observer, then for that reason, in order to consider that, what we take this pseudo force, that is FP, that is pseudo force, basically is equal to minus m into a. Basically, negative sign is telling that you need to apply the pseudo force in the opposite direction, in this direction, basically. Yes, this is a pseudo force and it is equal to m into a. Bas, itna hi karna hai. Did you get it? Yes, students, let me know. Okay, Ballari students. Okay, now let us try to understand this using a problem. Okay. Now the question says there is a trolley. Okay. There is a trolley, and there is a one pendulum type of mass. Now over here, the trolley is moving with the velocity. This is trolley. Okay. This is trolley. Yes. And with the acceleration A. Now students, if it is moving with the acceleration A, will this this body move something over here? ऐसे move करेगा ना? Yes or no? Students, let me know. Will it move something like this? Yes? Yes or no? So the question says, Yes, very good. The question says find theta when when m rests in equilibrium. When m rests in equilibrium. Students, once try this. I'm giving you 2 minutes of time to try it. Please once try it, students, and let me know. Please try it. You need to find theta when m is at rest. So here, the thing is, you can solve this problem over here using what? Using pseudo force. Using pseudo force. It will be much easier. Use the pseudo force to solve it. Let me know, students. I'm giving you 2 minutes of time. I want what is this theta? I'll explain you, but can you try it or not? Let me know. Amrita, good. Very good. Nice. Can anyone tell what is this theta? Yes, Madhya, that is good. But what is the value of theta? Okay. Okay, students. Should I solve it? I'll try to solve this now. Here, what will I do is I will keep the Badari students. That is not the right answer. I will keep the observer inside trolley. Inside trolley. So what will happen? If this is the trolley, can I keep the observer in the trolley? Now, students, you know that if it is moving with the acceleration A, then this guy will also move with the acceleration A. Yes or no? Yes or no, students? Now, students, you know that when you're trying to observe that object, then what? The body will come over here. Yes or no? देखो कार में जा रहे हो, ठीक है, एक ट्रॉली है, उसके अंदर एक बॉडी है. अगर ऐसा रखा है तो कार में अगर आगे जाओगे ना विद द फोर्स, तो वो ऐसा हो जाएगा ना. अगर मान लो ऐसे गाड़ी जा रहा है इस तरफ गाड़ी जा रहा है इस तरफ, and there is one object, so it will what come over here. So वो यही, I mean it will stand over here and it will be in equilibrium. ठीक है. Now they are basically asking this theta. What is this theta, students? They're asking for it. Simple, students, very good. Okay. Now, students, can I say if I do the FBD of it, as I said, since I'm inside this what trolley, I'm in what? In a non-inertial frame. Non-inertial frame. Yes or no? See, over here, there is a trolley. Okay. And there is a mass. Okay, there is a mass. Now, if I move with the acceleration A, this mass will come over here. And I want this angle theta. Yes. And I'm inside this observer. Now, students, you know that for this object will what? It will looks like it's at rest. Yes or no? Yes. Okay, just a second. Looks like it's at rest. Yes or no, students? Now, if that is the case, if I drew the FBD for this will be a non-inertial frame. Why? Because I am moving with the acceleration A. Yes or no? Now, if I draw the FBD, it will be something like this. Yes or no? See, there is a object of mass M. Now it will come over here. Yes, and it will be at equilibrium over here. Now I know this is angle theta. You know that if that is the case, what you need to do, if there is a non-inertial frame, you need to apply a pseudo force M into A. And you know that there is this M into G that comes into picture. Because why? Because it's already said that it is in equilibrium. क्योंकि अगर कार में जा रहे हो और एक ऑब्जेक्ट है, तो आप एक एक्सेलरेशन में जा रहे हो, तो वो ऐसा ही खड़ा रहेगा. ठीक है, वो ऐसे ही खड़ा रहेगा. Now, using the point object, like using the FBD, can I draw something like this? Yes? Yes or no, students? देखो, आपको पता है कि वो हैंग हो रहा है यहाँ से, तो एक टेंशन आएगा. तो can I draw something like this? This is the object. This one, basically I'm drawing this one. This is object. There is a tension that is acting. Yes? And you know that ये वाला theta है. Then if that is the case, this is also theta. And there is a force that is M into A that is acting. That is the pseudo force. That is a pseudo force. And students, you know that there is a mg that is acting. Yes? Yes or no, students? Now, if that is the case, can I okay, yes. So if that is the case, can I let's say resolve this t into two components? So it will be t cos theta and it will be t sin theta. Yes or no? Yes or no, students? Let me know. Yes or no? So can I write t cos theta is equal to mg? The first one, this equal to this, and also can I write this equal to this? That is what? T sin theta is equal to m into a. Now I want what? Theta basically. So can I do 2 divided by 1? So can I do t sin theta by t cos theta is equal to ma by mg. So m cancels out, t and t cancels out. So can I write it as tan theta equal to a by g? Yes? Yes, students, let me know. Yes or no? So basically I got what? Basically I got theta to be tan inverse of a by g. Yes? Tan inverse of a by g. This is your answer, students. This is your answer. Did you get it now? Yes? How do you solve it? How to solve the problem? Did you get it? Why inverse? Madhya, for which? For which? See, basically we want what? We want theta. अगर हमारे पास tan theta equal to a by g है, तो अगर हमें थीटा चाहिए तो क्या करना पड़ेगा? थीटा इक्वल टू tan इनवर्स करना पड़ेगा ना. सही है, ये करना ही पड़ेगा ना मदिया. हाँ, बस इसलिए मैंने की. Amrita, let me know. I didn't get you. Only for transverse, I didn't get you. What do you mean by it? You mean rectilinear motion. The motion is what? Rectilinear, you mean? Yes? Yeah? You were talking about this, Amrita? Okay. Others, let me know in the chat. Is it clear or not? See, try to solve problems using what? Using non-inertial frame. The only advantage is in non-inertial frame, you take acceleration to be 0. Yes or no? And what? There is a pseudo force that comes into picture. Yes, Uttarakhand students, very good. Others, let me know. Madiha, Sweetie, Ansari, Chittradurga, Uttarakhand, Tumkur, Davangere, Ballari, Suhaib, Suman. Yes, Chittradurga students. Okay, continue. What is your doubt? Chittradurga students, this force is due to what? The pseudo force. This is pseudo force. That is the pseudo force. देखो, जो इसका फोर्स है वो रेस्ट पे है. मैंने वही बोला ना. देखो, अगर आप इसके लिए एफबीडी बना रहे हो ना, तो जो फोर्स है वो तो रेस्ट पे है, उसके लिए एक्सीलरेशन नहीं हो रहा है ना. वो मैंने समझा, that is true चित्रगुप्त students, but the force that we are applying is a pseudo force. There will be a pseudo force. देखो पहली बात, अगर आप if you're moving in a car, and if you're inside the car, now the along your journey there will be this object will be something like this. ಹೌದಲ್ವಾ? ಸ್ವಲ್ಪ ಈಗ ಟಿಲ್ಟ್ ಆಗಿರ್ತದೆ. If the acceleration is zero, if my acceleration is zero, then what? You are telling that acceleration is zero. Yes or no? You are feeling that is at rest. If that is the case, if that is at rest, then it should come down, right? How it will stay up? That is the reason there is a pseudo force. There is a pseudo force. That pseudo force will have some acceleration. Why? Because I am having some acceleration. Yes. See, even if I'm at rest, there is some acceleration because the trolley is moving with the acceleration. Got it? Chitradurga students, let me know. Amrita tan inverts for pseudo force. Okay. I still didn't get you, but can you explain me once? Okay, nice. Now, if that is the case, students, try to solve another problem. Okay, there is this another problem. Try to solve it over here. We have time. We have 10 more minutes to try to solve it. I'll give you exactly 3 minutes of time. Okay. So you need to find the reading, of spring force. Spring force. Basically, it is asking you to find what? Tension. Okay, it is basically asking you to find the tension. If what is happening? There is a lift. There is a lift. Okay, and what is happening? There is one spring that is attached, and with that there is one pulley that is attached, and for that pulley there is this 1.5 kg mass is attached, and there is this 3 kg mass is attached. Okay, and it is moving with the acceleration g by 10. So please try to find it, student. You need to find what is tension. Try to solve it. And I'm giving a hint. Keep your observer over here. Keep your observer over here and try to find it. Okay? Is it good? If I'm keeping the observer over here, you know that this whole system will be at rest. But what? For him, there will be some acceleration A. That is what? G by 10. So please try to solve it, students. So I'm giving you exactly 3 minutes. It is G. Okay, it is G. It is G. G by 10. G by 10. This is basically what? Acceleration due to gravity. So please try to solve it. Please try to solve it, students. Tumko students, please check your answer. Okay, let me try to solve this. Okay, the problem was there was this what lift which was moving with a what acceleration g by 10, and there was this what pulley which was basically hanging with the string, and it had a mass what 1.5 kg, and it had a mass of what 3 kg. Yes. Okay, just a second. I need to draw it little more down. Okay, and what 3 kg. Now the question was to find. The question was to find the tension value. No students, simple students, check your answer. The question was to find what tension. Now here, what will I do is I will keep the observer over here. Okay. If I keep the observer over here, you know that this whole system is at rest. Yes or no? Dekho. The problem over here is if you keep the observer what over outside in the ground, then this is also moving. ये भी Hello students, sorry, there was some issue with the network suddenly. Let me know, can you hear me? Can you hear me, students? Can you see the screen? Can you hear me? Yes, clearly? Okay, okay. Now, if I do the video of this, so the tension that is acting, you know, there's a tension over here, there's a tension over here, yes, over here, and there is a mass that is acting 1.5, yes. Here also there is a tension that is acting, and there is this weight that is acting 1.5 g and 3 g. Yes or no, students? Let me know. Yes. Now, students, you know that over here there will be a pseudo force that is acting. That is what m into a, and there is a pseudo force that is acting m into a. Now, this will be basically m into g by 10, and it will be what m into g by 10. Yes or no? Because I'm keeping the over there, it is non-inertial inertial frame. Now, if that is the case, students, so can I write the two equations? For the first equation, it will be T minus 1.5 G by 10 minus mg by 10, which is equal to 1.5 A, because you know that there will be an acceleration of this pulley over here. Yes or no? Inside. So if that is the case, this is the first equation, and the second equation will be g by 10 plus 3g minus t equal to 3 into a. Yes, second equation है. Please try to solve this problem, students. Please try to solve this. Okay, this will be a homework question for you guys. This will be a homework. Yes, yes or no, students? And also, there are take the screenshot of it. Take the screenshot of this because this is also homework question for you. Yes, you need to solve these, students. And over here, there's another homework question, and this will be this another homework question. Please take the screenshot of it. Yes, students, let me know. Yes, students. So we'll do one thing. We are stopping this session here only. Okay. So there is a network problem. I don't know what is the network problem, but take this as the homework questions. Okay. Yes. Take these as homework questions. One is this one. Another is this one. Yes. And also this case. Okay. This case. This is also homework question. Okay, students. Please try to solve it. We'll have a dedicated class. Okay, don't worry. We'll be trying to solve everything over there, and we'll be having a dedicated class. Okay, dedicated class for what? JEE and NEET questions, and also these questions. Okay, these questions also homework questions. So, students, with this, we are at the end of NLM. Okay, we're at the end of NLM. Some from today's class, from tomorrow's class, we'll be talking about what? Work, power, energy. Yes. Okay. Students, thank you for attending today's class. Okay. Take care. Bye bye. YouTube students, take care. Bye bye.